my name is Monica Stidberg. I am a faculty specialist in the assessment office. My area of expertise is writing assessment. And I'm an educational psychologist by training, so I do have some knowledge about just teaching and learning in general. And
my name is Sarah Post. I'm from the math department. I'm also on the GE Foundations Board, working with the quantitative reasoning transition, and I've also been working in the math department with it. I've taught Math 100 a couple times in different ways, so I've been thinking about it a little bit and happy to discuss with you what I've been thinking and to get feedback on things.
Thank you all so much for coming, and as you heard, none of you are from the same department, and that is a good thing because the Foundation's quantitative reasoning requirement is for all students. And it needs to be a shared responsibility. Faculty from all fields, from the appropriate fields, need to contribute. So we're very happy to see you all here. Quick agenda. Assignment design general principles. We'll have a QR assignment example, several examples from Sarah. You will spend some time today working on your own assignment and talking to others about what you want to come up with, what your ideas are. Have some resources for you on the white handout, and then we'll do a wrap-up. We really want you to leave today being able to describe a quantitative reasoning assignment, a QR assignment that aligns with the Foundation's hallmarks and with the rubric. I want to get a sense of where you're at right now. And the green sheet is an activities sheet, so you can take a moment to jot down these questions, and then I'm going to ask you to share out loud, because we have a nice small group, but yep, we'll not record it. So these are the 2 sentences that I would like you to finish. To explain quantitative reasoning to first-year students, what would you say in 1 sentence? And regarding the Foundation's QR, what are you most concerned about? Yeah, I think today we'll go over some general principles with assignment design, and hopefully hearing some of those ideas will spark something that you will be able to use in your classroom to help your students succeed. Yeah, Any other concerns anyone wants to bring up? When the folks who shared, when you shared what you would say to students, you guys are right on the money. I mean, that is exactly what the general education folks would want you to say. This language is from the Foundation's quantitative reasoning hallmarks, which I've printed out on page 3 of the white handout. So, yeah. Apply mathematical concepts to the interpretation and analysis of quantifiable information, expressed numerically or graphically, in order to solve a wide range of problems. And then the box on the right, these are the abilities that are listed as part of the definition of QR. Understand and communicate quantitative information using such tools as variables, equations, graphs, charts, words, sentences. Apply math skills, judge reasonableness of results. That's understanding the magnitude part of that is associated with reasonableness of the results, and recognize the limits of mathematical or statistical methods. So that's the formal definition that Gen Ed has put forth for us. On page 1 of the handout, I'm just going to go over a few things that we know make good assignments. And you can keep these in mind as you think more about what you're going to be doing in your classroom. So the first one is aim slightly above what your students can do on their own. We know that the most important influence on student learning is students' prior knowledge. It's the #1 influence or factor that affects a student's learning is their prior knowledge, both what they know and their misconceptions. And when it comes to quantitative reasoning, there can be a lot of misconceptions that students have brought with them into the classroom, especially with like probability. There's just a lot of misunderstandings. So I encourage you to find out before you get down deep into your work, what do the students already know? And more importantly, see if you can find out what misunderstandings they have about the topic that you're going to introduce to them, or the skill. Yeah, it can be a test that you give them just a few questions. It can even be self-perception. You can even ask them, how would you rate your knowledge? Do you know it? Can you apply it? Right? You can ask them to self-assess, and that gives you a lot of information. Certainly, tap into that. Quick and simple, but we often forget to do it. And then it's hard to use the results sometimes. But it's worth doing, because as you know, once there's that misunderstanding at the beginning of the semester, it can snowball, and it can result in them never getting to the point you want them to be at the end of the semester.
I also have a question that, do you suggest to have this test during the class time, or doing as like a zero homework or something like that?
Yeah, zero homework, take home, or during the class, quick 10-minute check, knowledge check. Yeah, it can be done, whatever fits your situation, the number of students you have, right? It could be an online Google form that they do quickly for you. Productive climate. This is of particular importance if you're teaching first-year students and you're teaching a class that there's no prerequisite and it's quantitative reasoning. Because we know that math anxiety exists. And the students might come to your class in particular because it's not taught in mathematics. They might have a perception that is going to be easier because they're scared of math, not realizing that your class is going to draw on mathematical principles. So there's math anxiety quizzes available online. You can just Google for them and give a short one. Just giving that quiz helps students because then they feel like, oh, okay, it's okay to be a little nervous about this class, right? You can then reassure students and make uncertainty safe by doing things like having ungraded assignments, practice assignments, etc. And then you can explain your strategies to support all students. You're going to have students at all levels, probably, at quite a wide range of preparation if you're dealing with first-year students. So what are you going to offer them, or what can you offer that the university has? You know, the university has math tutoring, one-on-one, available online. We have the Math Emporium. We have the Learning Assistance Center. So help students be aware of these resources right away so that they don't feel like they're going to struggle. Productive climate also relates to your examples that you're using, because there's a practical component for quantitative reasoning. So to have a productive climate, you're going to think about what examples are you using, and are these examples diverse in terms of appealing to all genders, both sexes, multiple ethnicities, age groups, life experience, right? How varied can your examples be? All of that contributes to productive climate. Meaningful beyond the classroom, not only does it help student motivation, but it helps students transfer abstract principles to concrete application. We know that if you teach abstract principles only, that students won't be able to apply when they get into a real-world situation. So you have to teach it in context. Humans cannot transfer knowledge very well. It's fascinating research. Start with low stakes building block activities before a high stakes or a graded assignment. use what's called deliberate practice. So basically deliberate practice is just saying, hey, be sure to give students assignments aimed at improvement, not only aimed at you're being able to evaluate them. Does that make sense? So use assessment for learning, not only assessment of learning. So students do an assignment, it's not worth much grade, but you explain to them the importance of this assignment as a building block to a graded assignment, and then it's low stakes. It's important. And then give them timely feedback. Timely feedback is hard if you have a lot of students, like 70. So what I was doing when I had a lot of students, I would put up a common mistake, and I'd only address the common mistakes. So I'd put up, this is the common mistake that many of you made, here's how to fix it, here's what you might have been thinking, that way of thinking is incorrect, here's the right way to think about it, and just deal with the common problems. If you have a small class, definitely give personalized feedback. Metacognitive activities is very common in math. Very common now, because we know that students can get to the right answer with the wrong thinking. So ask metacognitive questions to help you make sure students are getting to the right answer using the right way of thinking about the problem. And I gave some examples on the handout. These are just questions about thinking and process and asking them to think how they would apply this strategy to new settings and so forth. Explicitly link activities and tasks to your learning outcomes, to the evaluation rubric that you're going to use, or exam questions. The reason this is important is because students can often and easily become confused if you use different words to refer to the same thing. So if you use the same language on the assignment, on the syllabus, on your learning outcomes, and on the evaluation grading criteria or in your exam questions, it helps students know what you're talking about because they're not yet fluent enough to interchange words that we know are interchangeable, but they don't know that they're interchangeable yet. So it builds coherence for the students. So those are some general principles related to things that you should be thinking about when you're designing an assignment. Hallmark 4 of quantitative reasoning gives you exactly what the learning outcomes should be for the class. You might have more, but you should not have fewer. Okay? You can do more than what's listed, but for the class to meet the requirement, this is the minimum that you should be helping students with. And so explicitly link your tasks, your activities with those skills. You can also look at the quantitative literacy value rubric to help you both design an assignment, talk to students about quantitative reasoning, and also, if appropriate, evaluate the student work using all or part of the rubric, or modify this rubric to meet your needs. The reason I'm suggesting this rubric is because the general education folks, this was the rubric and some of the work that they used to design the Hallmark 4. So there's actually a pretty good correspondence, almost a one-to-one correspondence between Hallmark 4, A through E, and the dimensions on the right-hand column of the rubric. So again, you can use this rubric to, as you design assignments, like Sarah said, if you're focusing only on one area, you can use some of this language to say, this is what I'm looking for. Okay? So, far left, yeah, sorry, left. I said the right, sorry. Is it the right or the left? The left. I have a problem with that. Sorry, I'm not good with my rights and lefts. So, I want you to take a moment. You can use the green sheet if it's helpful to you to answer this quick question. Maybe you have an idea in mind about an assignment, maybe not, but is there one or two or all? What dimensions of the rubric or Hallmark 4 A through E are you really interested in right now? Jot those down or circle them on the rubric. So one of the reasons I'm asking you to do this is because on the proposal form for quantitative reasoning, your programs have probably already completed it, but if they haven't, or if they're asked to revise it, one of the questions, several of the questions actually, which I've printed on page 2, the questions on the proposal form, so for your course to become quantitative reasoning, the proposal form asks you specifically, how are you going to have students demonstrate these 4A through E? So you have to be able to articulate that to a faculty group in a persuasive manner. But it's a friendly faculty group, so no fear. So what they ask you to do is provide sample assignments, and they do require you to do a real-world problem or a practical application explanation, and then again, A through E. Okay, so that's why I'm asking you to think about this right now. And I also want you to think about it as Sarah goes through her assignments, and think about how Sarah's interpreting these skills in her assignment, and hopefully you'll be able to use that as a spark or a jumping off point for your own assignment. You'll be able to see in practice. So we're moving from abstract to concrete.